Good day. This is your instructor, Engineer Carmel S. Borlat, and our topic for engineering data analysis is hypothesis testing. So to start with, the outline of my discussion will be, first we will discuss about hypothesis testing and its definition, um, the null hypothesis and alternative hypothesis will be discussed, and how to formulate one. Second, we will be tackling test on the mean of the normal distribution and variance unknown. Third will be test on the mean of normal distribution and with a known variance. Fourth will be the test on the variance and statistical deviation of the normal distribution. And lastly, we will discuss the test on population proportion. So our intended learning outcomes are the following. So the students will be able to discuss the idea of statistical significance and fundamentals behind the corresponding test, understand the principles underlying the hypothesis testing. Third, the students will be able to present the process for hypothesis and test procedures. Fourth, understand errors in hypothesis testing. Fifth, discuss the p-value tests. Sixth, understand the test of the means of normal distribution, variance known and variance unknown. 7. Understand the test on the variance and statistical deviation of normal distribution. 8. To be the students will be able to analyze the testing in the population proportion. And lastly, the students will be able to present the concept between statistical versus practical significance. Okay, um, these are the symbols from time to time that you should be familiarized with. So we have HO4, null hypothesis, H14, alternative hypothesis. So later on, we will discuss and define um, these hypotheses, null and alternative, so that you can make your own null and alternative hypothesis for a particular problem. Beta. So this is the probability of committing a type 2 error. Alpha is denotes for the probability of committing a type 1 error and is known as the level of significance. Sigma is variance. Then sigma x is for standard deviation of a sampling distribution mean. Then Greek letter mu, this one, which means the mean of the normal population. And of course, n is your sample size. X bar, this is X bar, your sample mean. And t distribution, it is a case where the population standard deviation is unknown. So t distribution will be used if the standard deviation of that population is unknown. And S for standard deviation. So this, this is a group of friends, and it is assumed that the mean age of these friends, of these 5 individuals, is equal to 50 years old. So based on their appearance, can you accept or reject the assumption that the mean age of this group of friends is 50 years old? Can you accept or reject it? But based on this alone, you can say that the assumption is not correct. Because basically, there are only 5 of them and dili po siya 50, di ba? Sa silang appearance. But how about if you will be given, if you are tasked to evaluate the mean age of a community. So, for example, of a country. So, diba, if you are familiar with the statement that the countries in Europe is aging. So, unsay pasabot ana. So, you cannot simply assume that their um, mean age of that particular community is 50, di ba? So, you have to do test. You have to validate. You have to test the assumption. And with that, you will use test statistics. So, an example of test statistics is the mean of the population. So, later on, we will discuss other test statistics as we go along. So, with this, if a group of 5 friends can directly reject the assumption that the mean age is 50 years old, but for a particular community, for a number of individual nga dako na ang population size, you cannot directly say that accept or reject the assumptions, di ba? So this is the reason why we do our testing. So hypothesis testing, the basic definition is that it is an assertion or a conjecture concerning one or more populations. So in our example, we have friends and a community mo na itong population. Then, assertion na to, or our conjecture is that the mean age of our group of friends is 50, di ba? So, statistical hypothesis testing and confidence interval estimation of parameters are the fundamental methods used at the data analysis stage of a comparative experiment in which the engineer is interested, for example, in comparing the mean of a population to a specified value. So, another example. Suppose that we are interested in the hours or minutes spent on Facebook of all the students in ES13 during the Christmas break. So, pila mo ka oras, pila mo ka minutes na Google sa Facebook atong uh, Christmas break per day. Suppose that our interest focuses on the mean minutes spent on Facebook, a parameter of which distribution. So specifically, we are interested in deciding whether or not the mean is 50 minutes per day. We may express this formally as, so the mean minutes per day that you spend on Facebook during the Christmas break is 50 minutes per day. That is our null hypothesis. Based on the situation, our null hypothesis is that you spend 50 minutes per day. And our alternative hypothesis is uh, the mean minutes spent per day is not equal to 50. So, dali ra siya no, mag-create ta og null hypothesis and alternative hypothesis. So, if ang null hypothesis na to, 50 minutes per day ang inyong gina-spend, then ang alternative is that dili siya equal to 50. So, basically, pwede tag 45 minutes, pwede ta og 1 hour, which is 60 minutes. That is our alternative hypothesis. Okay? So, on your own, makabalo na mo unsaon pagbuhat, diba? Og null and alternative hypothesis based on a particular problem. So, next is the presented alternative hypothesis sa previous slide is a two-sided alternative hypothesis. Ngano two-sided man siya atong balikon? Because your alternative hypothesis pwede siya not equal to 50. So, pwede siya 49.5, pwede siya 50.5 or 51.5, pwede siya less than all the values less than 50 and all the values less than greater than 50. So, pwede siya sa right side or sa left side of your critical value na 50. So, that is called a two-sided alternative hypothesis. And in some cases, and I think in most of problems, we are interested to formulate one-sided alternative hypothesis. One-sided pasabot, more specific compared to two-sided alternative. So instead of making an alternative hypothesis that is not equal to 50, then we will do this example. So your null is 50 minutes per day, and your first alternative hypothesis is less than 50 minutes per day. So that is your first set of null and alternative hypothesis. The second set is that your alternative hypothesis is greater than 50. So, pwede nimo siya buhatugin ani, and then pwede po siya kaning less than or greater than imuhang alternative hypothesis. Okay? Then, the structure of hypothesis testing problems is identical in all the applications that we will consider. So the null hypothesis is the hypothesis we wish to test. Rejection of the null hypothesis always leads to accepting the alternative hypothesis. So testing the hypothesis involves taking a random sample. So a random sample, for example, instead of testing all the students in ES13, we will only get a sample of 10 students per section. So, dili na ang entire population. And computing the test statistics from the sample data, and then using the test statistics to make a decision about the null hypothesis. So, our test statistic is the mean of the population in our example earlier. So, dili lang mean, di ba? Napay standard deviation, napay variance, napay proportion, and other test statistics involved. Another example, so that ma-master mo unsaon pagbuhat og alternative, null and alternative hypothesis. Okay, consider the propellant burning rate problem. So, this is a propellant. So, it is found basically in your mga hydrant, mga aerosol spray. So, nanay propellant ana sa ilalom. The null hypothesis is that the mean burning rate. So, atwang test statistics is mean gihapon ha. The mean burning rate is 50 centimeter per second. And the alternative is that it is not equal to 50 cm per second. So, in writing our null and alternative hypothesis, this is the answer. So you will have your null hypothesis and your alternative hypothesis. Based on our problem, the mean burning rate is 50 cm per second, and alternative is not equal to 50 cm per second. So, the sample mean can take on many different values. Suppose that if 48.5 is less than or equal to the sample mean, less than or equal to 51.5, we will not reject the null hypothesis, which is this one. The mean is equal to 50. And if either the sample mean is less than 48.5 or the sample mean is greater than 51.5, we will reject the null hypothesis in favor of the alternative hypothesis, which is our mean is not equal to 50. This is the illustrated in figure 9.1. So, this figure. So, we will reject our null hypothesis if the mean is less than 48.5 and greater than 51.5. So, the values of the sample mean x bar that are less than 48.5 and greater than 51.5 are constitute the critical region for the test. So, Um, please take note of this word here. Critical region, ang mga values nga naa sa less than 48.5 and greater than 51.5. While all values that are in the interval, which is in between of this range, form a region for which we will fail to reject the null hypothesis. So by convention, this is usually called the acceptance region. Remember this, ano, acceptance region. So the boundaries between the critical region and the acceptance region are called critical values. In our example, the critical values are 48.5 and 51.5. It is customary to state conclusions relative to null hypothesis, H sub O. Therefore, we reject in favor we reject the null hypothesis in favor of the alternative hypothesis if the test statistics falls in the critical region, and fail to reject the, the null hypothesis if it is in the acceptance region. So if all the values ma-fall dinhi less than 48.5 and greater than 51.5, if all the values mapunta dinhi, then automatically we will reject our null hypothesis. But if the result of our test statistics falls between this area, these values here, between 48.5 to 51.5, then we fail to reject our null hypothesis. Okay? So there are two types of error in hypothesis testing. First is the type 1 error and the type 2 error. So if we reject the null hypothesis, H sub O, in favor of the alternative hypothesis, when in fact H sub O is really true. This type of error is called type 1 error. And if we fail to reject the null hypothesis when it is false, this type of error is called a type 2 error. So because our decision is based on random variables, probabilities can be associated with type 1 and type 2 errors. So the probability of making a type 1 error is denoted as alpha. Remember. So it is the probability of committing type 1 error when you reject the null hypothesis, when in fact the null hypothesis is true. That is our type 1 error. And then it is sometimes called the significance level or the alpha error. So in the propellant burning rate example, a type 1 error occurs when either the sample mean is greater than 51.5 or the sample mean is less than 48.5. When the true mean burning rate is 50 centimeter per second. So previously, in the discussion of Engineer Dagsa, she uh, presented to you how to compute the z values, diba, of a particular critical values. So in this example, our critical value is 48.5 and 51.5. Okay, so alpha is the probability that the sample mean is less than 48.5 when the actual uh, population mean is 50. Plus, it is the probability of the sample mean to be greater than 51.5 when the population mean, the mu, is 50. So the corresponding z values that correspond to the critical values are this one, z sub 1 and z sub 2. Okay, this formula is already given previous discussions of Engineer Lovely. So therefore, the alpha is the probability that uh, the probability for sample mean to be less than 48.5 and the sample mean to be greater than 51.5. So this one. And the z values here. So alpha is 0.057. So this implies that 50, let's just make it percentage, 5.76% of all random samples would lead to rejection of the hypothesis when the true mean burning rate is really 50 centimeter per second. So when to get the uh, critical region here, so alpha divided by 2, we'll get here, and alpha divided by 2, because this one is, and kani siya plus kani nga area is equal to alpha, so that is why you have to divide by 2. Okay? Okay. Type 2 error, this is, we call it beta error. We must have a specific alternative hypothesis. So that is, we must have a particular value of mu 1. For example, suppose it is important to reject the null hypothesis. The null hypothesis H sub 0, wherein mu is equals to 50, whenever the mean burning rate mu is greater than 52 centimeters per second or less than 48 centimeters per second. We could calculate the probability of type 2 error, beta, for the values mu is equals to 52 and mu is equals to 48, and use these results to tell us something about how the test procedure would perform. So specifically, how will the test procedure work if we will test to detect, that is, we wish to reject H sub 0 for a mean value of mu is equals to 52 or mu is equals to 48. Because of symmetry, it is necessary only to evaluate one of these two cases. Say, find the probability of accepting the null hypothesis H sub O is equals to 50 centimeters per second when the true mean is equal to 52 centimeter. So, in equation form, beta is equals to the probability of a type 2 error. So, it is the probability that we fail to reject the H sub O, the null hypothesis, when the null hypothesis is false. So in our previous example where we calculate the mean burning rate of a propellant, so uh, the normal distribution of the figure is the distribution of test statistics x mean, which is the sample mean, when the null hypothesis H sub 0 is equals to 50 centimeter is true. And the normal distribution on the right of the distribution of x sub x bar when the alternative hypothesis is true and the value of the mean is 52. So beta, or the type 2 error, will occur when the probability is 48.5 is less than or equal to x sub x bar, or the sample mean, is less than 251.5 when the true value of mu is 52. So this is the figure 9.3. In this side, there the probability of a type 2 error when mu is equals to 52 and our null hypothesis is 50. So this is the probability, the shaded part here. And it is in this, in the right side, it is the probability of having a beta error, type 2 error, when the mu is equals to 50.5 and n is equals to 10. So the corresponding z values to 48.5 and 51.5 when mu is equals to 52 are z sub 1, just substitute this value to the correct mu over 0.79 is equals to this one, and z sub 2 is this one. So if we are testing h sub o, therefore the beta, the percentage of having a type 2 error is 0.2643. So if we are testing null hypothesis against the alternative hypothesis, and the true value of the mean is equal to mu is also 52, then the probability that we will fail to reject the false hypothesis, the false null hypothesis, is 26%. So by symmetry, the true value of the mean is 48, and the value of beta will also be 0.2643 or 26.43%. So some of the differences of type 1 versus type 2 error. So type 1, based on sample data, we must allow for the possibility of errors. Type 1 error is rejecting the null hypothesis when it is true. And it is the probability of making a type 1 error when the null hypothesis is true as an equality is called the level of significance. Okay, take note of that term, level of significance, or the alpha. Application of hypothesis testing that only control the type 1 error are often called significance test. While type 2 error is accepting the null hypothesis when it is false. It is difficult to control for the probability of making a type 2 error, because statisticians avoid the risk of making a type 2 error by using do not reject HO or not accept H sub O. So this is the sample and direct comparison of the two errors. So we have 4 important points to remember. The first is the size of the critical region, and consequently the probability of type 1 error alpha can always be reduced by appropriate selection of the critical values. Second, type 1 and type 2 errors are related. A decrease in the probability of type 1 error will always result to an increase in the probability of the another, so provided that the sample size n does not change. Third, an increase in sample size will generally reduce both alpha and beta errors, provided that the critical values are held constant. Fourth, when the null hypothesis is false, beta increases as the true value of the parameter approaches the value hypothesized in the null hypothesis. The value of beta decreases as the difference between the true mean and hypothesized value increases. Okay, so in determining the beta, remember that in determining the beta, we have to have a specific alternative hypothesis. So this is why we have to study one-sided alternative hypothesis. So you cannot have h sub 1 is not equal to certain values, diba? So dapat if your h sub o, if your null hypothesis is equal to mu sub o, then your alternative hypothesis should be mu is less than mu sub o or greater than mu sub o, and not equal to. So one-tailed test. The location of the critical region for one-sided test is usually easy to determine. Simply visualize the behavior of the test statistics if the null hypothesis is true and place the critical region in the appropriate end or tail of the distribution. So generally, the inequality in alternative hypothesis points in the direction of the critical region. So these are the general procedures in testing your hypothesis. First, from the problem context, we have to identify the parameter of interest. In our given example, it is the mean burning rate. Second, state null hypothesis, H sub O, or H sub O is equals to mu is equals to 50 centimeter per second. Then specify an appropriate alternative hypothesis. So our alternative hypothesis in our previous example is that H sub 1 mu is less than 50 or greater than 50. Fourth, choose a significance value of alpha. So our alpha is 0.05, or our level of significance 0.05. So determine the appropriate test statistics. So our test statistics used is Z statistics. Then state the rejection region for the statistics. 7. Compute any necessary sample quantities. Substitute this into the equation for the last and compute that value. Then 9. Decide, 8, decide whether or not your null hypothesis should be rejected and report that in the problem context. So self-review. Your answers to these problems will be submitted in your LMS. So uh, first is you have these exercises will help you formulate your null hypothesis and your alternative hypothesis. So we have 5 problems here, and I will create an activity in the LMS so that you can upload your answers there. Okay? Thank you for listening.